In this video, we're going to conclude our discussion of functions. We're going to start by going back to something we talked about last time a little bit, and that's the idea of pass by value versus pass by reference. This is a really important concept. We're going to move on soon to arrays, and then later on, when you take data structures, this idea of these memory manipulations are very important. Okay, so in a nutshell, when we pass by reference to a function, we're not just, so the default is pass by value, right? If you send a variable x to a function, then it's going to take the current value of x and just send that value. So there are no side effects back in the calling program. Where with pass by reference, you're going to send an actual memory address of the variable. So any changes made actually have a side effect back in main, okay? So I've got a sample program here that I wanted to talk about and show you a diagram. The book has a lot of diagrams that are probably better than mine, so you should look through that as well. So in this case, I've got this input one, which it's a void program. It takes an A and a B, but we can only return one of those. So we're kind of stuck. So the void function doesn't return anything. In input two, I've added the ampersand here, which means that's a pass by reference. Up here's a pass by value. That's a pass by reference, which means I'm sending the actual memory addresses. And note that I'm naming things the same in main and the functions in this example, but you don't have to, okay? They're totally independent, the names are. So, and it does the same thing, input two different numbers. So down here, I've got my numbers A, B, C, and D, okay, that I'm initializing. The first time I'm sending A and B, okay, I'm actually sending the values of A and B, okay. The values of A and B by default are 0 and 0. Those come up here. I'm getting new A and new B, but that's it, okay. So when I go to print them out, it should print out 0, okay. Whereas the second one, I'm sending the variables C and D. I'm sending their actual memory address. So here, when I enter the two numbers here, those will still have value back here. Okay, that's the idea. Okay, so let me go ahead and compile this real quick. Okay, and if I enter 1 and 2 for those numbers, you see that they're still 0, 0 back in main. But the 3, 4 actually have value. Okay, so let's take a look at what's going on in my poorly conceived memory diagram here. Okay, so this is what happens when we pass by value. Okay, so the blue squares here represent the memory that the operating system gives your program. Okay, so that's all we have. When we start int main, the operating system is going to give us some bit of memory. Okay, inside of here, I've declared two integers. So these are two integer sized boxes labeled A and B. Now I've got the A and B in there, but actually there would be values in here. The values would be 0 at this point, okay? When we call the first input 1, okay, it's given its own memory space distinct from that of main, okay? It's created its own two memory variables, okay, memory locations inside of its memory space that initially have 0. We're entering the two numbers here. In my example, I did a 1 and a 2. Those are stored there, okay? When this goes out of scope, so when the end of this function happens, all of this is erased and we're back to this position. And there was no transfer back to the calling program, okay? So that's the issue there. Now, if we look at, and let me make sure, I'm going to share that again just to make sure you're able to see that, because sometimes it does weird things. Okay, so when we do a pass by reference, on the other hand, we still have the same initial setup, okay, with 0s here and 0s here. But this time, in the memory area that we set up for our input 2 function, these boxes should have dotted lines around them because they're really pointing to these boxes down here. Okay, they're the same. Okay, they're just a link between these. So when I enter values in these boxes here, then they have, then you were changing the ones back in main, basically. That's how that works. Okay, so again, that's a really important concept that I want to make sure that you guys have. And if not, ask questions and we can certainly do some more stuff with that. Okay. So the next thing that we want to talk about is the different scopes for that our variables can have. Okay, so we have different places that the variables have value. Okay, and some of you have seen, in fact, most of you probably have seen this error message before that something is not in scope. Okay, so we're going to talk about what that means. So with scope, you've got basically two scopes. There's global scope, and then there's going to be local scope. Okay, so this is something new for us. This idea that we're going to be able to declare variables that are accessible everywhere. So it wasn't an issue before when we only had int main, but now we've got a bunch of functions we're adding. What if you want there to be a variable that you can get to from all those functions? Okay. You do that by declaring variables. Notice that I'm outside of int, the int add I'm going to do, I'm outside of int main. Okay. I'm out here before anything. Okay. Anything that I declare here is going to be available everywhere. Okay. So let's look at when we're in int main. I'm declaring X and Y here. Those are local variables to main. Okay. I can access G since G was up here defined as global. Okay. Now notice that it gets even more local than that. It's local to the block that it's declared in. So in this case, we declared it in the block for main. So when it's available between this curly bracket and that curly bracket, right? In this case of a loop, I'm declaring the int I inside of the for loop. Okay. So it's only visible inside that for loop. If I try to access it from outside the for loop, I'm going to get an error. Okay. So down here in add, I'm sending in X and Y as parameters. Okay. Note that these X and Y are not the same X and Y as in main since I'm not passing by reference. Okay. I'm declaring a new variable Z. Z only has scope here. I can't look at it in main. Okay. But I also can get to G. So that's what I have here. So that's the idea of scope. So when it tells you your variable is out of scope, that's what's going on. Now, what often happens with the global variables, and I usually put a global variable tag in my program, even if I'm not going to use it, just like I use a defined variable, just so I know where it's at. Okay, put a label there, a comment. Okay, we often do global constants. Okay, so a global constant then, again, C++ doesn't enforce it, but programming etiquette, I guess, or the way we do things, what you want to do, you want to name your constants in all capital letters. And they're the only variables that should be named that. Again, it's not enforced, it's just a matter of habit. So we use the constant keyword, const, the type of variable it is, its name. Again, you want to make that in all uppercase letters. And you have to set the value here because once you've declared a constant variable, it can't change ever. Okay, so it's that forever. So that's why we have to set it there. Okay. And because we're declaring it here, it's available everywhere. Okay. So that's used often in programs for interest rates or things like that. Okay. Again, more in the book about all of this stuff, but I did want to go over some of it in more detail. Okay. So the next thing is this idea of overloading functions. Okay. So an overloaded function simply means we can have the same function name as long as we have a different function signature. So what's a function signature? A function signature is the number and type of parameters. Okay. So in this case, I've created this dumb program called doublet. It's a int function that takes an int and returns 2 times that int. Okay. If I wanted to create another version of this program, okay, it would have to be different in some way. Okay, so I could do a doublet that takes a double. Okay, that would be perfectly okay. And again, it could be, well, I could just copy this. It could be more or less the same thing. except I change that to a double. Change that to a double. Okay. And it's going to be fine. Things are not going to be confused. Okay. Again, it's the return type and the number and types of variables that matter. Okay. So if you had a function name that took one integer and the same function name that took two integers, that's fine too. Okay. All that's going to be okay. And again, the compiler will figure out which one you mean when it goes to match up those parameters. Okay. So if I send double it, let's go back up to my main here. If I say double it 5, okay, of course that wouldn't do anything. I'd have to print it out. But if I send that, it knows since this is an integer to take this version of the program. Or if I say double it 5.3, it's a comma. Where'd my point go? There's my point, 5.3. Then that is going to call the version of the program that takes a double. Okay. So that's just a way to avoid having to come up with a bunch of different names for similar items. Okay, so next thing we're going to talk about is this idea of having default parameters, which can be kind of useful. Okay, so let's talk about that. So a default parameter then is if you have a function here we have is a volume function with integers. Okay, and if it's the volume for this would be for a square or a rectangle or whatever, or a prism if it's in 3 dimensions. Okay, so if we're going to have the same function, we may or may not want that third dimension to be a real value. If we set it equal to 1 by default, then it's not going to change how it's done. Okay, so I have this volume function. I have x, I have y, and with z, I'm adding in. This is in the function prototype. I'm adding in that it has a default variable. Okay, you can only do that once. If I just define the function here, I could put it there as well. But what I can't do when I define my function down here, since I've already said equal 1, I can't do that twice. Okay, so how this works, if you send the function here, volume, with 2, 2, 2, for example, then it's going to say x is 2, y is 2, and z is 2, and give us back 8. If I send it with just 2, 2, it's going to take x is 2, y is 2. It's going to default z to 1 and make it 2-dimensional, not 3-dimensional. Okay. So just to take a look at that one, not that it's all that exciting. Gives us an 8 and the 4. Okay. So use those, when there are default values that are usually going to be the case or often the case. And I think that just makes things, makes your coding a little more straightforward, I think. Okay. So the last thing we're going to talk about is an idea of static variables. Okay. So a static variable is a variable that remains in memory from when it's created until the program stops executing. Okay. So it's always going to be there. The other kind of variable is an automatic variable. An automatic variable gets allocated at the when it first gets initialized. It's allocated then in that block, and it's going to stay allocated until that block ends. So that block could be an if, could be a while, it could be a function, it could be any of those things. Okay. So it's the automatic variables that we normally use. It's what we've done so far. Okay. Note that if we create a global variable is a static variable. It's available everywhere. Okay. The whole time the program's running. Okay. But we can also create static variables wherever we want. Okay. And when we do that, they are also available everywhere. Okay. So we have a test function here, and then in int main, we're going to create an integer called count, and then we're going to do this for count is equal to 1, count less than or equal to 5, count plus plus. we're going to call test. Okay. In test, we're declaring int x as static. Okay. So without doing that, every time we called test, x would have its own value. It would default to whatever it defaulted to, right? It'd be 0 every time. Okay. But because we're declaring it as static, it's only going to take that 0 value the first time. Okay. Every other time that we call test, that static doesn't go away when we're out of scope on test the first time. Okay. So when count's equal to 1, we call test the static. We don't have x. So now x is in memory. Okay. We're going to set an integer of y. We're going to redefine x, redefine y, and we're going to print out what's happening. At this mark here, y goes away. Okay, y is out of scope. Y has no value. X, though, is going to be what it was before. Okay, so x is 2. Okay, it's still 2. X doesn't go away. We come back here, count is now equal to 2. We don't redeclare it because we already have. Okay, x is still 2. Y is going to be 10 like it was before. X is now 4 and so forth. Okay. So by declaring it static, x doesn't go away. It has persistence between calls to the function in ways that y doesn't. Okay. Take a look at how this works. We see that while y is the same every time, that x is going to maintain that value all the way until the end of the program. Okay. So again, that's what a static variable will do for you. Okay. So again, the static, once it's declared, and you can declare it in this function, that's perfectly okay. But it's going to have value everywhere. It'll have value out here. It's going to have value the whole time. Okay. So that's how the static variables work. Okay. So we're starting to get into what makes C++ C++ and the power and danger that it has. And that's it. We're already able, we're going to be even more able to directly manipulate the memory, which you can't do in Python or Java or any of those languages. Okay. So with that comes power, with that comes some danger. So we'll talk more about that as we go along. Okay. So make sure that you're reading along in the textbook to supplement what I'm talking about. Work through the programs in the book that they work out for you to make sure you understand them. If you have questions about that, let me know. Okay. And in addition to the homework that I give you, it's if you're not 100% certain that you have it down, then do more. There are more homework problems in the back of each chapter. There are plenty of homework problems online that you can look for. Okay. Or if you find that you're getting it, you want to go further, then go further. I'll be happy to look at whatever programs you create to let you know what's going wrong if something's going wrong. Okay. We have students at a bunch of different levels in this class, and that's always the case. So do what you have to do. Okay. I will warn you again, or at least bring it up again. Make sure that the homework that you don't do in class, make sure that it's your own work and you're not getting too much help on it. Okay. And when you're in class, if you ask me or ask one of the student assistants, make sure that you understand what you're turning in. Okay. If you're going to be a CS major or software engineering major or whatever you're going to be, MIS major, these are skills you're going to need. So just getting through this class is not the goal. The goal is to develop the skill so you can use it as you go forward. Okay. If you have any questions about any of that, make sure that you let me know.